Okay, next we're going to go over limits and the slope of a tangent. Okay, they've asked us in example 3 to find the slope of the tangent to this curve at the point of x is equal to 3. Okay, so we know from our formula before that our slope of a tangent can be expressed in terms of our formula. Okay, and we're going to write it all out here. So the slope, which is our m, can be expressed as the limit of the change in x as it approaches 0. So that's what I was talking about, that extremely small change in x, which is essentially the change in y divided by the change in x. Okay, so the limit as x approaches 0, so an infinitely small change in x is represented by change in y over change in x, which is also equal to, and this is how we are going to normally write most of our questions now, the limit of h as it approaches 0, and h represents a number in this formula we have. Our formula is the function of a plus h minus the function of a divided by h. Okay, so this is the formula we're going to be using. We're going to break this formula down into sections and solve it one piece at a time, then put it all together. So we're first going to deal with our function of a, f at a. Then we'll deal with our function of f at a plus h. Okay, so let's go down a little. F at a. F at a is essentially our formula. Okay, and actually instead of a, they've used x in terms of this. But I'm going to rewrite the formula in terms of the letter a. F at a is negative a squared plus 4a plus 1. All I've done is rewritten this formula above, the formula for the curve, with the variable a. The reason they don't write it with a is because when we graph things, we deal with an x and y axis. Okay, so that's why they've represented it in terms of x and y. Well, our formula deals with a, so I've replaced the x with just the variable a. And we're finding this, f at a, when a is equal to 3, or in other words, when x was equal to 3. That's what this was. Our x is equal to 3, so our function of a is going to be f at 3. So I now go f at 3 is equal to, and I plug 3 into our equation. We have negative 3 squared plus 4 times 3 plus 1. That gives us negative 9 plus 12 plus 1, which is 4. Okay. So what they discovered is f at 3, or in our formula above, f at a is equal to the number 4. Okay. Oh, wrong one. We'll relate it back to our yellow. So we figured out that part of the formula, our f at a. The next thing we're going to do is figure out the f at a plus h. So f at a plus h. Well, that's that same formula, except we're plugging in negative a plus h squared plus 4 times a plus h plus 1. Now I technically have an a value. Okay. Our a value, can I see it if I do that? Oh, that's not good. Our a value is 3. So I'm going to replace the a with the term 3. So what we're actually finding is f at 3 plus h. Okay. Which again is negative 3 plus h squared plus 4, 3 plus h plus 1. Okay. We're then going to simplify this part of the formula. When we go to simplify it, so we expand our term here, it becomes negative. We get h squared plus 6h plus 9 plus 4h plus 12 plus 1, negative h squared minus 6h minus 9 plus 4h plus 13 is equal to negative h squared minus 2h. Negative 9 plus 3 is 4. Okay. So here's our simplified version of it. That is what our f at a plus h is. I guess we'll zoom out so you can see it a bit. So we figured out the two top parts of the formula. We're now going to take these values and plug them in. So our limit, that's not an L. Our limit as h approaches 0 is, and instead of writing in our f at a plus h, we're going to write this part of the formula in. We have our negative h squared minus 2h plus 4. And then f at a was the number 4. Okay, all divided by h. We'll just highlight this so you guys saw again. That was the green part we found above, which is our f at a plus h, if you remember. And this was our f at a, if you guys remember from up here. Okay, so we've plugged those two numbers in. Again, we're going to simplify now. So as we go through this limit, is equal to the limit of h as it approaches 0. Okay, and we're going to start simplifying. So I'm going to take these brackets off. And when I take the brackets off, I'm going to have positive 4 and negative 4. What's going to happen to those two? They're going to cancel each other out. Okay, so when we drop those brackets, we're going to be left with negative h squared minus 2h, all divided by h. Our numerator, what can I do with the numerator? Remember our goal, we want to actually get rid of this h on the bottom. So we're going to see if we can factor an h out. That's kind of what our goal is here. So we're going to factor out that h. We get the limit, LIM, there we go, of h approaching 0 is, and we factor out our h, we're left with negative h minus 2 divided by h. What happens to the two h's? They drop off. Our limit as h approaches 0 is negative h minus 2. Okay? Well, if h is approaching 0, or essentially becoming the number 0, our limit is equal to what number? Negative 2. Think of it like we've plugged in an infinitely small number, or 0 in for h. Okay? That's when we've taken this h at 0, plugged it in. So our rate of change is negative 2 at that point. So after all that work, tangent to the curve at that point, the rate of change is negative 2 at that point. Okay? There's a part B and a part C. I'm just going to try to give an idea of what that looks like. Part B, they ask us to determine the equation of the tangent. The equation of the tangent line is the change in y over change in x. I'll just kind of graph what they're trying to say here. That way we don't jump through all that extra work. Okay. So when they're asking for the equation of the tangent, technically what you're doing is, well, a change in y over a change in x. Remember, that's our tangent. And our numbers, we actually had numbers this time. Well, y minus 4, that was our y2, and x minus 3. Okay? And we know that this was all equal to the rate of change, which was negative 2. We had just solved that. When we equate this to linear form, where eventually when we set it equal to y, we get y is equal to negative 2x plus 10. Okay? And they've given us a linear function. That curve is a quadratic facing downwards, so it looks something like this. Again, we're just going to sketch this. It looks something like that. That was the quadratic they gave us, let's say, which was y was equal to negative x squared plus 4x plus 1. Okay? And we found the rate of change at the point 3, so we'll say this is where x is equal to 3 at this point here. Well, the rate of change is the line tangent, or the slope of the tangent line to this, which means this is the equation of our line here. This line can be represented with that equation, and the rate of change, or the slope, is negative 2, specifically at that point there.